Equilibria, finding Kp, part 8. Hydrogen and bromine were mixed together in a flask in a ratio 1:1. At 450 Kelvin temperature equilibrium, total pressure was 140 kilopascal and the mole fraction of bromine gas was 0.35. Hydrogen gas plus bromine gas giving 2 hydrogen bromide gas. Calculate the partial pressures of each gas and Kp value. Okay, so we're given the mole fraction in this calculation and the total pressure. We know the ratio is 1:1 for bromine gas and hydrogen gas. We're to find the partial pressure of each of them and to find the Kp value. The mole fraction given for the bromine is 0.35. Because they have the ratio 1:1, then the mole fraction for hydrogen will be 0.35. This is not the mole, these are the mole fraction. Therefore, the total mole fraction in a closed system is 1. And we could find the mole fraction for hydrogen bromide by adding these 2 mole fraction of bromine and hydrogen, which is 0.7, and take it away from 1. That will give the mole fraction of hydrogen bromide. So hydrogen bromide will be 0.3. How do we get that? That was 0.35 plus 0.35 plus the hydrogen bromide mole fraction will be equal to 1. So to find the hydrogen bromide mole fraction, we basically take 0.7 from 1 to get 0.3. Now we know the mole fraction. We know the partial pressure is going to be mole fraction times total pressure. So if we times the mole fraction by the total pressure, we will get for hydrogen, we get 0.35 times 140 kilopascal. So that will be 49 kilopascal. Likewise, for bromine, it will be 49 kilopascal. For hydrogen bromide, it will be 42 kilopascal. Now we can use that for the calculation of Kp. To find the Kp, we will have for the hydrogen bromide is going to be 42 kilopascal squared over 49 kilopascal times 49 kilopascal. And that will give 0.735. While there's no unit, because the unit for this is to power 2 and this is power 1 and power 1. Again, that the bottom unit is power 2, so the 2 cancel out, so that there's no unit in this situation. So the Kp has no unit.